In this video, you will learn about difference between neutral atom and ion, types of ions that are cation and anion. You will learn about ionization energy and periodic trend in atomic size and ionization energy. Let's see the difference between neutral atoms and ions. An atom that has equal number of protons and electrons is called a neutral atom. Calcium atom that I have on the left in this image have 20 protons and 20 electrons. Protons altogether giving a charge of positive 20 and electrons are giving a charge of minus 20. And the net charge on this calcium atom is 0 because plus 20 and minus 20 are canceling each other. An atom in which electron-proton balance is not maintained has a net charge and is called ion. An atom or molecule can have net electric charge due to loss or gain of one or more electrons. During a chemical reaction, this calcium that was initially neutral lost 2 electrons and resulting atom that does not have equal number of proton and electron. In this atom where the protons and electrons are not in balance, we have positive 20 for protons and negative 18 for electrons. So this will give it a net charge of positive 2. Let's see types of ions. Ions with a negative charge are called anions. In anions, number of electrons are more than the number of protons, and this can happen if the electrons are being added to a neutral atom. Ions with positive charge are called cations, and in cations, the number of protons are more than the number of electrons, and this can happen if you remove the electron from a neutral atom. Did you notice that we are talking about the loss or gain of electron, not the proton? Because the number of protons are the identity of the element and will never change in a chemical reaction. It is only electrons that will add or remove from an atom during a chemical reaction. In this slide, I have a silicon atom with 14 protons and 14 electrons. For 14 protons, we have positive 14 charge and 14 electrons have negative 14, and they both neutralize each other, and the net charge on the silicon is 0. If during a chemical reaction, this silicon atom gain 1 electron, so this additional electron will give an additional negative charge to this silicon, and the net charge on the silicon will be negative 1, and it will called as silicon anion. If the neutral silicon atom lose 1 electron during a chemical reaction, then we will have more positive inside the atom and less negative. And the difference between these positive and negative will give the net charge of the silicon. And the net charge in this example will be positive 1, and the silicon will called as silicon cation. Let's do some practice to find number of protons, electrons, and neutrons for ions. So in the first example, I have hydrogen plus 1, which is hydrogen cation. Its mass number is 1. Atomic number for any element you can get from the periodic table. It never changes. It is the identity of the element. Atomic number is 1, and this atomic number is actually the number of protons. To find the number of electrons for a cation, to find the number of electrons for a cation, if it is a cation, means it have 1 less electron than the total number of proton. So if total number of protons is 1, 1 less than this number is going to be 0. Neutrons, you have to find a difference between mass number and atomic number. and the difference is going to come out 0. So we have 0 electrons for this hydrogen. For calcium plus 2, atomic number is 20, so its number of proton is 20 as well. Number of electron is going to be 2 less than 20, so number of electron is 18. Number of neutron is going to be the difference between these two, which is 26. For iron plus 2, its atomic number you can get from the periodic table, so 26 is the atomic number. Mass number is also 20, number of proton is also 26. Number of electron will be 2 less than number of protons, so it is going to be 24. Number of neutron is the difference between these two, so will be 30. For oxygen, oxygen is anion with 2 more electrons. -2 means 2 more electrons. So atomic number is 8, means number of protons are 8. 2 more electrons than protons means you have 10 electrons. For number of neutrons, you're going to find a difference between these two. So number of neutrons is 8. For nitrogen, which is -3, means it has 3 more electrons. Atomic number 7 means number of proton is 7, number of electrons are 3 more than protons, going to be 10, and the number of neutron is the difference between these two. Number of neutrons is 8. Let's look at the next topic, which is ionization energy. The minimum amount of energy required to remove an electron from an atom is called the first ionization energy. And the energy that is required to remove the second electron is called second ionization energy, and so on for the third and fourth electron. Here you can see we have a lithium atom with 3 protons and 3 electrons outside the nucleus. Electrons are negatively charged and protons are positively charged, and there is electrostatic force of attraction between these negative and positively charged particles. In order to remove electron from this atom, we have to break this electrostatic force of attraction. And the energy that is required to remove this electrostatic force of attraction is called ionization energy. So in order to remove this electron, we have to give certain energy to break this bond, and then we can easily remove the electron from here. Now the amount of energy that is required to break this bond depends on how strong this electrostatic force of attraction is between this positive and negative particle. And according to Coulomb's law, this force of attraction depends on the distance between these particles. So if you have a smaller atom like hydrogen, where we have only one shell and the electron is very close to the nucleus, then the force of attraction between that electron and the nucleus will be very strong, and you have to put a lot of energy in order to break that force of attraction. But if you compare that energy with the energy that is required to remove the electron from the atom of group 6 or 7 element, where the valence electron is in the 7th shell or in the 6th shell, then there is a huge difference between the positively charged nucleus and the negatively charged electron that is in the valence shell. So the energy required to remove that electron will be less if you are comparing it with the energy required to remove the electron from the hydrogen atom. Let's look at some trends. The first trend that we want to see is the periodic trend in atomic size. Let's learn about periodic trend in atomic size. And before we look at these trends that we have here, let's have a quick review what we have learned from the Bohr's atomic theory. According to Bohr's atomic theory, we have shells outside the nucleus, The number of shells starts from n equals 1 and they go up to the infinity. Each shell can hold a maximum number of electrons, and that maximum number of electrons can be determined with the help of 2n square formula. And based on that, when we fill electron for the group 1a, we have this type of electron filling. Like we have hydrogen that have only one electron. Its one electron will go in the first shell. Lithium have 3 electrons. 2 electrons will go in the first shell, and once this first shell is completely filled, the 1 electron will go in the second shell. For sodium, we have 11 electrons. 2 electrons will go in the first shell, 8 electrons will go in the second shell, and the last electron will go in the third shell. And when you look at this, you can see that these elements in the first period have only 1 shell occupied. Elements in the second period have 2 shells occupied all the way from left to right. Elements in the third period have 3 shells occupied. Elements in the fourth period have 4 shells occupied, and so on as you move down the periodic table. So atomic radius increases as you go down a group, and atomic radius decreases as you go from left to right in a period. And this is explained in the Bohr's atomic theory. As you go down the group, the number of occupied shells increasing. That is the reason that the atomic radius increases. Atomic radius decreases as you go from left to right in a period. And the reason for that is that nuclear charge is being increased as you go from left to right in a period. And this increased nuclear charge, or the increased positive charge, pulls the electron inward, resulting in decreasing atomic size. So let's do some practice. Arrange the following elements in the order of increasing atomic radius. So the first thing we have to do is we have to identify where these elements are in the periodic table. Okay, we have magnesium here, sulfur, silicon, phosphorus, and sodium. Okay. So we identified our elements, and remember the atomic size trend is that atomic size decreases as you go along the period. All these elements are in one period. So sodium will be the largest and sulfur will be the smallest. Now the order that you have to give is the increasing atomic radius, means you should start with the smallest one. So the order is going to be, you have sulfur, phosphorus, silicon, magnesium, and sodium. Okay, let's do another practice. You guys can pause the video and do it yourself, and after that play and check your answer. So let's find where these elements are in the periodic table. We have sodium here, we have rubidium, potassium, cesium, and lithium. All these elements are from the same group, and we know that the periodic size increases as you go down the group, right? So if you are going to write down increasing atomic radius order, you should start from the smallest one, which is lithium, and then sodium, potassium, rubidium, and cesium. Let's look at the next trend. The next trend is the trend in ionization energy. Remember, the ionization energy is the amount of energy that is required to remove the electron from the valence shell. And the reason we have to put energy to remove this valence electron is because this valence electron and the positively charged nucleus have some force of attraction here. And this force of attraction depend on the size or the distance between the nucleus and the valence electron. If the distance is small or if the atomic radius is small, we have to put more energy because there's strong force of attraction. If the distance is large for the larger atoms, then we have to put small amount of energy to remove the electron from this valence shell. So ionization energy decreases as you go down a group, and ionization energy increases as you go from left to right in a period. So as you go down a group, you know that the atomic size increases. So if atomic size is increasing, means we need less amount of energy to remove that electron. That is the reason that ionization energy decreases as you go down a group. Ionization energy increases as you go left to right in a period, and the reason for that is that atomic size is decreasing as you go left to right in a period, and from the smaller size atoms, it takes a lot of energy to remove the ionization energy, to remove the electron.